look for in a factoring problem? First of all, always look for a least common multiple or GCF. GCF, yeah, greatest common factor. Yeah, you always, when factoring, talking about factoring here, always look for, first of all, GCF. Then, on a binomial, if you've got two terms, you know, if it's just two terms, you look for either squares or cubes, right? And if it's squares, there's one of them that factors and the other one doesn't. Which one factors on squares? The difference, yeah. Difference of squares factors, and a sum of squares, what about it? That's prime, okay? So on squares, difference of squares factors. Now what about cubes? How do you factor cubes? Well, there's a formula, right? Sum or difference of cubes, we'll use a formula, and I'll mention it more in just a second. Now, if we have a trinomial, three terms, and we've already taken the GCF out, trinomial, you try to factor it how? Two binomials. And then if it's four terms, well, we did what? Grouping, yeah. Okay, so that's, we hadn't really laid it all out like this. Here is just kind of a rundown of all the factoring we did. Binomials, you know what to do, trinomials, and that's what we did. Okay? All right, so I've got a few, 12 little examples here of what we, all right, so just factor through here. All right, so number one, x cubed y, 18x cubed y minus 63x squared y cubed plus 9x squared y. Well, like we said, always GCF. Look for GCF, and yeah, there's certainly common amongst all those. Matter of fact, 18, 63, and 9 have what in common? 9. X's, I've got x cubed, x squared, and x squared, so I've got x squared in common. And then y, well, I'll just have y in common, don't I? Because these two just have y in them, so all I could do there is y for the y's. So pull that out, 9x squared y. Now do this one, let's see, just dividing it, so that'd be 2. X cubed, take out an x squared, you got an x. Y, take out a y, you got 1. So it's just 2x there. 63, take out a 9, you got 7. Take out x squared, it's gone. Take out y, you got y squared. So 7y squared minus 7y squared for the middle. With me on that? And then the last one, I give this one because, yeah, you're taking out 9x squared y, so you're taking out all of it. But you can't just say no term there left. There is a placeholder. You need a 1 in place there. Yeah, we are dividing this by 9x squared y, so yeah, that divides, and yeah, you get 1. Okay? All right, number 2, 49p squared minus 121. So that's brings us to our binomial scenario here. There's no GCF, but it is two terms, so I look for squares or cubes. What do I have here? I do have squares. 49 is 7 squared, and 121 may not be one you're totally familiar with, but that is a square. What is it? Square. 11 squared. So I do have squares, and it is a difference, so it factors into two binomials, like a lot of them do, but for 49p squared, I do the 7 and 7p and the 7p, and then the 121 is minus 11 and positive 11, and that'll do it. Number 3. 36 x squared plus 25. Well, they are squares again, 6 squared and 5 squared, but what about it? It's prime, isn't it? Yeah, if it's plus between the squares, a sum of squares is prime. You can't factor a sum of squares like you can a difference of squares over the real numbers. Okay? So number 3 is prime. Number 4, 27 x cubed plus 125. Again, binomial. But it's not squares. 27 is not a square. 125 is not a square. So it's not squares. So we look for cubes also. And I do have cubes here, don't I? 3 cubed is 27. 5 cubed is 125. So yeah, I have a cubes, and then there's a sum of cubes. Well, how do I do that? It's a formula, isn't it? If it's a sum of cubes, it's a cubed plus b cubed. That's what you've got. Then how does it work? Well, it goes a plus b. Whatever you cube here is a, and whatever you cube here is b. So you just go a plus b, and then what? Well, you do a times a squared, minus ab, a times b, and then b squared. How that works. So what do we got here? Well, the a, I'd do 3x, wouldn't I? B is 5, and that sign is plus. Then I'd multiply that by, well, like I said, you take that times itself, so that'd be 3x times 3x would be 9x squared. That times that's 15x, and that's a minus between it, and then this times this is 25. And that's how number 4 factors. With me on that? All right. Number 5. 5 is x squared minus 8x minus 20. No GCF, but it's a trinomial, so we're through our 2 binomial. Parentheses way, all right? And it's a nice just x squared one, so it's just x and x. Got minus 20, which, you know, minus 20, you got minus, so one of them is minus, so it's minus 5 and 4, minus 4 and 5, 10 and 2, minus 2 and 10. Yeah, there's various ones you can do. Which one is it? Negative 10 and 2, why? Because if you add negative 10 plus 2, you get negative 8, and that just so happens to match the middle there. So yeah, what they add to be should match what the middle is. So that would be minus 10, positive 2. Okay. How that one factors. Number 4. On number 4, could I do it any further? Yeah, usually you can try, but it usually doesn't factor anymore. You're talking about this one? That is a good point. You should always look to factor more if you can, but on the trinomials, usually this one doesn't factor anymore. If it's a trinomial, not the trinomials, the cubes, sum of cubes, this formula, that usually part doesn't count. That's a good question though. All right, number 6. Number 6, we've got 1,000 y cubed minus 343 b cubed. What do you see there? Cubes? 10 cubed? 7 cubed. Yeah, 343 is a cube, 7 cubed. So we're here again to cubes. But it's a difference of cubes, but that's a similar formula, isn't it? To the sum of cubes, it's a cubed minus b cubed. That factors, it's a minus b. Then you do a squared plus a times b plus b squared. Right? Yeah, it changes to minus here, and that's a plus there. All right, so how's this one going to work? Well, A would be 10y. B would be 7b. And it's minus between them, same sign there. All right, then we do 10y times 10y, that's 100y squared. And then 10y times 7b is 70yb, or by. And it's a plus. It's always the opposite sign here. And then it's plus 7b is 49b squared. Whoop, forgot a square there, didn't I? 100y squared. Right there. Should be a square there. Do that right? Besides that one little mess up there? Okay. All right, number 7. Number 7, y squared minus 25y plus 24. Got another trinomial, so that's 2 binomials. Y squared, so that's y, and that's y. Now for the other 2 slots, I do the 24. Well, 24 is 8 and 3, 6 and 4, 2 and 12. None of those seem to work because you add them together, you don't get 25. What do I have to do here? Well, one thing I have to do is think about, you can always do 2 and 12. None of those work. One thing you always think about, I get 25 by doing what? 1 and 24. However, that's positive 25. How am I going to get negative 25? Both negative, right? Negative 1 and negative 24 is 24, positive. And it adds to be negative 25, doesn't it? Negative 1 plus negative 24 is negative 25. So it's minus 1 and minus 24. Yeah, don't forget about 1 in the number. Sometimes you use it. And the other thing, positive, you can do 2 negatives to make a positive. Okay. Question on number 7. Number 8. Well, number 8 is similar. Question? Number 8 is 6x squared plus 7x minus 20. Yeah, the thing on these, with the number here being different than just 1x squared, just x squared, it's got a 6x squared, so that changes things up just a little bit. We have to go through it, but for 6x squared, I can do 3x and 2x. Now, for 20, 10 and 2, minus 10 and positive 2, or vice versa, 5 and 4, 20 and 1. Like I said, you could reverse those with the minus. Of course, none of them had to be 7, but that's okay here because, I'm going to have to plug them in and try them anyway. If I try, like a negative 10 and a positive 2 here, to get it to be 7, what I'm going to have to check is this times this is 6x, this times this is minus 20x. Those should have to be the negative 7x if this is going to work, but that's not a go there, is it? So I have to try others. 5 and 4. Of course, I could reverse those, do all sorts of things, do the 2 here and the 10 there, but I think it's going to have to be a 5 and a 4. Let's try that. That'll be 12x and 10x. Nope, that's not it. So let's reverse them, you saying? Do the 4 here and the 5 here. Negative 4 and a positive 5. See if that works. That and that's 15x. That and that's minus 8x. Hey, that's 7x, which matches with what I need it to match. So you might have to go through several tries there, but hopefully ultimately you get there to the right one. Okay?